In this video, we will learn how to find out the optimal consumption bundle given the utility function. The question is given utility function is x plus 2 times y plus 1. X and y are the two goods. Consumer consumes. Price of good x is $4. Price of good y is $6. And income of the consumer is $130. We need to find out the optimal consumption bundle, that is x star, y star. Options are being given. We need to find out the correct option. Okay. So what happens here? We want to maximize the consumer's utility, that is u is equal to, if I solve it here, so it will become x into y is xy, plus then we have x into 1 is x, plus then we have y into 2 which is 2y, then we 2 into 1 is 2. This is our utility function. Consumer wants to maximize this utility subject to the budget constraint, that will be the price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. So specifically here price of good x is 4, so we have 4 times x, plus price of good y is 6, so we have 6 times y should be equal to m, which is the income of the consumer, which is 130. Okay, so consumer wants to maximize this utility subject to this budget constraint. And here if I draw the simple graph, it will look like this. So we have good x on the horizontal axis, good y on the vertical axis with the given budget line. Let us draw this budget line. Consumer wants to reach to the highest possible utility, and highest possible satisfaction will be at a point where the budget line and utility, what we call the indifference curves, are tangent to each other. That will give us the optimal consumption bundle. Okay. Now what happens at that very point, and let me see if I have the space. Okay, so at this point what happens, our marginal rate of substitution will be equal to the ratio of the prices, price of x upon price of good y. MRS denotes the slope of the indifference curve, and this ratio denotes the slope of the budget line. So at this point what happens, our MRS should be equal to the ratio of the prices, price of x upon price of y. MRS, as we know, it is the ratio of the marginal utility of good x upon marginal utility of good y, and it should be equal to price of x upon price of y. So price of x is 4, price of y is 6. Okay. Now MUX, that is marginal utility of good x, means the change in the utility due to the change in the consumption of good x, divided by marginal utility of good y, means the change in the total utility due to the change in the consumption of good y. It should be equal to 4 upon 6, which is 2 upon 3. Here it means du upon dx means the partial derivative of this utility function with respect to good x. So partially differentiating this with respect to x, derivative of x in the first term is 1, so we are left with y, plus derivative of x is 1, so we are left with 1, and derivative of this term and this term is 0 because we are taking partials with respect to x, divided by, likewise we take the derivatives with respect to good y. So derivative of y is 1, we are left with x in the denominator. Derivative of this term and this term is 0, rather derivative of this term and the last term is 0 because we are taking partials with respect to y, and derivative of y in the third term is 1, so we are left with 2, and we equate it with the price ratio. Now let us do some cross multiplication here. So we have 3 times y plus 1 is equal to 2 times x plus 2. Solving further, so we get 3y plus 3 is equal to 2x plus 4, or we get here 3y is equal to 2x plus 4, transpose it here, it gets subtracted, so we get here 3. Okay, so 3y is equal to 2x plus 1, 2x plus 1, or y is equal to, implies y will be equal to, divide both sides by 3, we get 2x upon 3 plus 1 upon 3. Okay. Now we plug this value of y, or let us rewrite it like this. So we have 2x plus 1 upon 3. This value into the budget constraint here. Okay. I don't have the space, and let me create some space. Okay, so everything is okay. So plug y is equal to this stuff into this budget constraint. So we have 4 times x plus 6 times the value of y is this 2x plus 1 upon 3 should be equal to 130. So 3 1s are 3 2s are 6. So we are left with 4x plus 2 2s are 4x plus 2 is equal to 130, which implies we get 8x. 8x is equal to, transpose this term, it gets subtracted. So 130 minus 2 is 128, or x will be equal to 128 upon 8, which will be equal to 8 1s are 8, 8 6s are 48. That means x star will be equal to 16. So consumer will consume 16 units of good eggs. To find out the units of good y, like x is equal to 16 in this equation, so y is equal to 2 times 16 plus 1 upon 3. So we get here 32 plus 1 upon 3, which is equal to 33 upon 3, which is equal to 11. That means y star will be equal to 11. That means consumer will consume 16 units of good eggs and 11 units of good egg. Why? To maximize his utility. So the correct option should be D option here. I hope I make myself clear in this video. Thank you.